and classifying angles as well as how to name angles and identify them in pictures. Here's just some vocabulary to start. An angle consists of two different rays with the same endpoint. The sides of an angle are the rays. The rays are the sides of the angles, the rays that form it. Vertex. In an angle, the endpoint is the vertex of the angle. So the endpoints of these rays were their common endpoint. Measure of an angle. In angle AOB, the measure is equal to the absolute value of the difference between the real numbers for OA and OB. So if you were measuring this on a protractor where it looks like, half of a circle, that's what this is referring to. If you had your your angle, say that your angle was like this, then the angle measure would be like the number that's here on the protractor minus the number that's here, because they're not always lining up perfectly. Maybe it's like here, and so that would be the number that you see here on the protractor minus the number here to get the measure of that angle. An acute angle is an angle that measures between 0 and 90 degrees. A right angle is an angle that measures exactly 90 degrees. And an obtuse angle is an angle that measures between 90 degrees and 180 degrees. A straight angle is an angle that measures exactly 180 degrees. And a straight angle looks like a straight line. So if you see this, it is an angle. It's called a straight angle. It's also a line. So it gets a little bit confusing, but you need to remember that if you see a straight line, you need to know that that measure all the way across is 180 degrees. We'll be using that a lot to solve problems in the future. Congruent angles, angles with the same measure. And an angle bisector is a ray that divides an angle into two congruent angles. Some very important vocabulary. Here we're talking about how you can name angles. You use 3 letters. The middle letter must be the vertex, and the other 2 letters are points from each side of the angle. Use only the vertex of the angle is another way. And you do that only if it is the only one in the picture. So if you look at this one, there's 2 pictures right here. There's this angle up here and this angle down here. The second angle on the bottom, you cannot call it angle B because there's more than one angle at the point B. And so you can't use option number 2 when you're naming it. Option number 3 is to label it with a number, like how this has a number 1 in it, and call it angle 1. So this angle here can be called angle ABC with a little angle symbol in front, can be called angle CBA, can be called angle B, or it can be called angle 1. The one below here cannot be called angle B. So on the second one, you cannot say angle B. That would be wrong. So you have multiple angles here. You've got ABC, you've got CBA. Those are the same angle, and angle 1. So we're naming that top angle. Naming this angle down here, you could say CBD, DBC, or angle 2. And then you have a third angle, which is 1 and 2 together. So you could call it angle ABD, or you could call it angle DBA. So we can also call that DBA. But you cannot use B because there's 3 angles at B. The angle addition postulate says if B is in the interior of angle AOC, so here's angle AOC and B is somewhere in the inside there, then you can add the measure of angle AOB plus the measure of angle BOC equal to the measure of angle AOC. It's very important that you have the writing like this where it's M of the angle and you have your symbols and your names correct and that you're adding them equal to the third one. It's a very important formula for us to know, again, the notation is very important. The second part here says if AOC is a straight angle, then, well, being a straight angle, we know that it adds together to create a straight line, meaning that it totals at 180 degrees. So we're going to write a very similar statement for adding these together. So the measure of angle AOB, just naming that one, and the measure of angle BOC, putting those together, should add to 180 because they're making that straight line, that straight angle. So here we have a sample problem, two actually, using the same picture. It says if measure of RST is 50, so here's RST, they're saying it's 50 for this problem, and RSW, so R to S to W, is the whole thing, 125. Then we want to find this angle right here. Well, we can do 125 minus 50. And so 125 minus 50 is 75 degrees. For the second one, I'm going to erase that there so I can reuse my picture. Okay, so on the second one, they said that angle RST is 45 degrees and RSW is 110. So very similar, 110 minus 45 is going to give us 65. So that's 65 degrees for that angle. And then the last part here is these two problems. Says if the measure of GEF, so GEF is 90 minus X, and they said the measure of angle DEG is 6X. Well, together they're making a straight line, so together they'll add to 180 degrees. And so to find X, we're going to do 6X plus 90 minus X equals 180. So 6X minus X combines to 5X plus 90 equals 180. Subtracting the 90, 5X equals 90. And then dividing by 5, X equals 18. And then to find the measure of DEG, DEG is 6 times that, so 6 times 18 will give you that degree measure of 108 degrees. So we've got two answers here, solving for X and solving for our angle. This one here is using the same picture, so we're going to do that one as well. So if DEG is, so DEG is that one there, so they're saying that that is, get that out of the way there, 2X plus 24. And then they said GEF, so that's the other part, together they're going to make a straight line. So I'm going to put this together here. So GEF, this part over here, was 6X minus 20. And so together they're making a straight line again. So again, it's 180 degrees when we put them together. You can combine your like terms before you write your equation. 2X and 6X is 8X. Positive 24 and negative 20 is positive 4. 180 there. So subtracting the 4, 8X, 176, and dividing by 8, X ends up being 22. And so we know that X is 22, and finding DEG, DEG is going to be 2 times 22 plus 24. So 2 times 22 plus 24 is going to be 108 again. All right, so just some problems from there. One thing we didn't see in these notes that I'm just now noticing is we did not see an angle bisector question. So I'm just going to throw a picture up here of an angle bisector and just give you a heads up about that. So if we're told that we have an angle bisector, then it splits the angle equally. And so this would be kind of how your picture would look where these two are congruent, and whatever expression is here would be equal to the expression over here. So this would be a matter of setting them equal and solving, whereas here you're adding them together to a total degree measure. Same with these, where you added them to a total degree measure that they gave you.